Right now, the autonomous agent market is stalling. Inside experimental sandboxes, AI agents perform flawlessly, but the moment they hit production-grade enterprise deployments, they completely fail. The friction comes down to architecture. Current large language models are probabilistic black boxes. They process queries by calculating the next most likely answer. Enterprise compliance, however, does not run on statistical probability. It requires glass box traceability, a transparent environment where every decision can be mapped back to a verified, factual origin. In a live corporate environment, agents navigate massive context windows, strict privacy rules, and fragmented data. Crushed under that weight, the black box workflow shatters. Organizations try to solve this by managing technical debt or by increasing the parameter count of their models. But throwing a larger probabilistic model at an enterprise compliance problem does not create traceability. The flaw is in the underlying infrastructure. To achieve scalable data autonomy, enterprises must abandon probabilistic models for memory and logic, and instead build upon a deterministic infrastructure. The industry's default attempt to fix AI memory is standard retrieval augmented generation, or RAG, typically powered by a vector database like Pinecone. Looking at a standard vector database search, text is processed by turning it into numbers and searching for mathematical averages. When a query looks for its nearest neighbor, it routinely pulls a statistically similar data node that is factually incorrect. This single mathematical error creates context pollution. The agent ingests the bad node, corrupts the surrounding data, and outputs a high-risk AI hallucination. The traditional alternative for heavily regulated sectors is migrating to massive graph databases like Neo4j or deploying bespoke platforms like Palantir. These systems prioritize exact relationships, but they fail to scale efficiently. They demand massive bespoke engineering, strict manual schema rules, and extreme operational overhead from highly specialized human teams. Engineers are left with a losing compromise: accept the factual inaccuracy of vectors, or take on the unscalable, expensive complexity of bespoke graphs. The Operational Data Engine, or ODE, is a deterministic replacement built specifically to solve this context management imperative. The system operates on a low IQ to operate philosophy. It provides a highly controlled, padded room for virtual data, absorbing the intense system complexity so the human operator does not have to. The foundational layer of the ODE is its associative knowledge management, or AKM, architecture. Rather than forcing data into rigid files, an AKM layer forms a mesh hovering above the existing databases. It unifies isolated information by mapping direct links based entirely on context. Crucially, it links these silos without altering the source databases. The foundation remains completely secure. By linking context automatically, the AKM layer replaces expensive, bespoke graph engineering with an automatic, self-managing schema. Even with perfectly mapped data, standard architectures suffer from a critical flaw: time blindness. They restrict an AI's context window to flat, present-day snapshots. The ODE definitive advantage is treating time itself as a structural, navigable dimension of the data. Rotating the network to reveal a temporal z-axis, we see the ODE continuously preserves historical system states for perfect auditing. Compliance teams can literally time travel through the data. Sliding backward along the timeline forces the schema to regress, recreating the exact past data context. This absolute traceability guarantees regulatory adherence. It replaces the algorithmic guesswork of traditional LLMs with fully explainable reasoning backed by deterministic proof. By solving the problem of time blindness, the ODE creates the verifiable environment necessary for trustably private agents to function within strict regulatory frameworks. For an architecture to survive at an enterprise level, the deployment workflow has to be frictionless. It requires day-zero integration without forcing teams into massive stack overhauls. The ODE meets engineers directly in their workflows across 3 delivery layers. First is the ODE API. It specializes in unicorn and dark horse detection, successfully surfacing high-value anomalies that traditional average prioritizing searches miss. Next is the ODE SDK. It bypasses traditional IT security hurdles with zero permission fussing. empowering engineers to immediately protect their context windows. Finally, the Model Context Protocol serves as the strategic interoperability engine. It replaces taxing manual context authoring with an industry standard, granting agents instant zero-shot enrichment without vendor lock-in. This three-tiered delivery ecosystem drives the ODE's core sub-30-minute value metric. Technical leads can evaluate hypothetical scenarios in a safe virtual sandbox and prove the system's validity before writing a single line of permanent production code. This deterministic infrastructure currently operates at massive scale through CloudnineAI's RHEL-1 platform, a flagship operational data engine with a follow-the-sun workforce of 7,000 employees. RHEL-1 is the intelligent connective tissue for open finance. External fintech streams flow into the hub, becoming automatically mapped and linked. Managing this flow lets RHEL-1 handle dynamic legal variables like PREPS compliance and class action tracking. The institution operates under the rigorous European Markets in Crypto Assets Framework, or MiCA. To comply, it utilizes RHEL-1's glass box traceability to provide the high-confidence, verifiable intelligence required for securely storing digital private keys. Furthermore, by utilizing the navigable time dimension, compliance teams successfully automate complex ESG and climate reporting by deterministically linking external variables to verified historical states. Even as the institution continuously adds new partners to its ecosystem, RHEL-1 ensures the digital value chain remains transparent, unified, and historically accurate. This exact deterministic infrastructure, currently managing complex context for global finance, translates directly to the critical challenges of enterprise healthcare networks. Healthcare systems suffer from massive, disconnected clinical silos. The OD's associative knowledge management solves this by unifying fragmented health data based on context without modifying the strict source databases. By replacing probabilistic guesses with deterministic links, the engine ensures medical outputs are grounded in verified data points, addressing the root cause of clinical hallucinations. When you apply a navigable time dimension to these complex medical records, compliance teams gain perfect, time-travel-enabled medical auditing capabilities, allowing them to verify the exact state of a patient's chart at any precise moment in the past. A deterministic glass box operational data engine provides the necessary infrastructure for organizations transitioning toward the next generation of autonomous enterprise applications.